I'm Anil Kumar, and in this video we are going to connect velocity time graph with displacement time graph. Well, question for you. What is the difference between displacement and distance? We do have a video where we have plotted for the same graph distance time graph. I hope you can appreciate the difference. Now let us understand. Displacement is a quantity which has direction. So if you are going away, then the distance is increasing, but if you are approaching, then distance between the two positions decreases, and displacement is the net distance between your initial and the final position, right? So displacement could be positive or negative. Displacement could be at times increasing or decreasing. As far as distance is concerned, it will always be decreasing in either direction you may go, right? That is the base. Now let's start developing displacement time graph from the given velocity time graph. So as you know, the relation between distance, velocity and time is distance equals to speed into time. This I'm giving all scalar quantities here. Okay, but what we are really talking about are vector quantities. So in vector quantities, what we have to do is we have to see the direction also. So whenever velocity is negative, distance will be towards the object, so the displacement will decrease and we'll have to take it out from the initial position. Okay, let's begin. So when we start with this, object is starting from initial position, which is 0. In first 5 seconds, the velocity increases from 0 to 10. Now, within this period, how much distance is covered by the object? Well, the average velocity during this time is 10 plus 0 divided by 2, which is 5. If 5 is the average velocity and object moves for 5 seconds with average velocity of 5, then the displacement should be 25, correct? So in the first phase, we have a displacement of 25. Well, there's an alternate way to find the answer, and that is by finding area under the curve. Area under velocity graph gives you displacement, I should say absolute value of displacement will be distance. So area under the curve, let me write down here, area under curve equals to distance. Okay, let me write distance here, and when we are talking about displacement, we'll think about direction, right? So initially, when the body is moving away, velocity is positive, or when the velocity is positive, body is moving away, so the displacement is positive. So we'll take this as positive. So in first 5 seconds, we calculated it is 25, and we can also find that value by calculating area under the curve. Now area is half base into height. Base is 5, height is 10. 10 times 5, 50, half of that, 25. So we get our displacement in the first 5 seconds. Let us make appropriate scale here and then draw displacement time graph. Okay, so we'll use the same units for the time. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So we have time in seconds, 5, 10, 15, and 20. That is the time in seconds. We got 25. So 1, 2, 3, 4, 5. We'll make this as 100 meters. Okay, 100 meters. 1, 2, 3, 4, 5. That becomes 200. 1, 2, 3, 4, 5, 300. 1, 2, 3, 4, 5, 400, right? Well, let me write displacement here, and the units will be meters per second. Okay, so displacement will be in meters, correct? Displacement is in meters, time is in seconds. Okay, so what we get here, that the object moves from a position, so we'll calling that as 0, and in 5 seconds it covers a distance of 25 meters. So in 5 seconds it is 25 meters, 20, and then 5 is close to 20, so there it is. So that is our displacement in the first 5 seconds. Now let us consider the displacement in next 5 seconds. Here the velocity increases from 10 to 30, right? So we can find area under this graph. Area is area of this rectangle, which is 10 times 5, 50. Area of the triangle, which is 30 minus 10 is 20. 20 times 5 divided by 2. So 20 divided by 5 is 10. Okay, 50, right? So 20 divided by 2 is 10 times 5 is 50. So we get 100 meters, right? So we add, because since it's going away, so the displacement adds on, a body or the object moves further away by 100 meters. So if I add 100 to this existing value of 25, let me write 25 here, then I get 125, right? So I have 125. So 125 is the position when it is 10 seconds. So okay, 10 seconds, 125. Okay, let's connect. There we go, right? Now, object moves at a constant speed of 30 meters per second for 5 seconds, right? So since it is constant, it adds on in the same direction, and this area is 30 times 5, 150. Okay, so we'll add 150 to 125. So 50, 150 is 275. So we come here, 275. So 275 at 15. So 15, 300, 20 less, and then 5 less. Okay, we'll connect these points and we get 275. Now the last part, velocity is decreasing, right? Velocity is decreasing. It decreases from 30 to 20, right? But still it is positive. It is not negative. Do you understand? Since it is still positive, displacement is, object is still moving away, correct? So this also adds up. And what do you get here? You get area, which is, we can have a triangle and a rectangle. Now the rectangle has an area of 20 times 5. Okay, 20 times 5, which is 100. Okay, let me write 100 here. And then this triangle has a height of 10. Half of 10 is 5. 5 times 5, 25. So 125. So let us add 125 to this. When you add 125, you get 400, correct? So you get 400 at 20, which is kind of here. Let us join them. Right? So the displacement is increasing all the way from 0 to 400 meters, and that is how it should look like, and that is how our graph should be. I hope you understand and appreciate how we can translate velocity to a displacement graph. Okay, I hope that's absolutely clear. Thank you and all the best.